Thank you, Dr. Asula. Next up, we have a panel led by Roger Grace by Roger Grace Associates. Take it away, Roger.
Good morning, good afternoon, wherever you are. It's an honor and a pleasure to be here, and thank you for the opportunity, Questex, to put this together. When I first started talking to Lucia about this, the title really grabbed me, and and why it grabbed me is because you'll see in an upcoming slide, it fell in very, very nicely to what I've been proposing for the last 5 or 7 years. And the reason for bringing Dr. Zhu and Michelle Farrington in on this program was because they were going to talk about, or they are expert in areas of printed flexible and functional fabric sensors. So that's kind of where I'm doing a lot of my work right now in my market research and working with my clients. And I'm delighted to know that without my input, Lucia came up with that great topic of next wave, because what we're going to do here is talk about waves. So the session overview, we've got myself and 3 additional speakers. I understand that you'll be able to get these presentations, but in the... What's happening? Something happened? Boom. Sorry about that. So, as I was saying, I've put the names and the emails of the different speakers in the event that you have questions for them. Nobody has told me that they won't answer your questions. So there you are. We got some very, very expert people that are willing to be available to you. And I would encourage you, if we don't get to your questions, and I certainly encourage you to send in some questions, that you can talk to these people directly, and there are their emails. So this is a slide that got me excited, and I put this slide together several years ago. And it's my opinion that, like in most technologies, we have waves of innovation. And my waves of innovation presentation here, or slide, is driven by what I call platforms. And I've defined 4 platforms. The first one being discrete mechanical, the second MEMS and silicon based, and the next one printed flexible, which Dr. Zhu will talk about, and the last one, functional fabrics. And our colleague from Yole did a superb job talking about MEMS and silicon, so I won't spend a great deal of time there. But one of the things that I think is important is you can see, and this came out very, very clearly in my most recent study on the MEMS commercialization report card, that we're seeing more maturity coming in the MEMS area. There's certainly new innovative things, but I consider them incremental advances, not breakthroughs. I like to think that there's some major breakthrough opportunities in printed, flexible, and functional fabrics, and I'm going to defer to my colleagues who follow me to address that. One of the things that's really important to keep in mind is, we talk about the concept of commercialization, and that means bringing products from concept into the marketplace. Professor Steve Walsh at University of New Mexico and I put this study together many, many years ago, and basically came out to determine that it took about 30 years to bring a product to market to full commercialization. So while we're seeing MEMS here, most of the MEMS have come to full commercialization, but there were new technologies that were presented by our Yole colleague that are still evolving. But by and large, the majority of, in my opinion, MEMS technology has been commercialized. The real challenge is going to be, again, in functional fabrics and printed flexible. So the final comment here is why am I so bullish on these two areas? And the reason, as an engineer and marketing person, is that people that are developing products develop them because they're being driven by certain things, and they're being driven by what is considered to be benefits to the user. And in this slide here, we show these four different areas of printed, flexible, stretchable, and functional fabrics. And um, two of the items for a person to design a product with these in them will be a cost and functionality trade-off. And what's so interesting and unique is that I believe that every engineer, as I was one day, has an engineering toolkit. And that engineer's responsibility is to go into that toolkit and find the optimum solution to that functional system block diagram that they're putting together to create a product. And these two technologies are two new tools in the toolkit. So having made that introduction, I will turn the presentation over to my dear colleague and expert Mark Venn.
Thank you, Roger. Appreciate being on the panel, and hope to have a really robust discussion on this topic. It's fascinating to me, the kind of usage models that really have kind of emerged on the scene, and are continuing to evolve over time. And the things that are so interesting about this category is what sensor whether we're talking about MEMS-based sensors or really the topic that Roger brought up, and that is this whole idea of printed, flexible, stretchable ingredients that allow you to create these impossibly thin sensors, that they're enabling sensors to go into form factors and products that in years past could never be comprehended into those solutions. Sensors now have the ability to have long range capabilities. So from a communication standpoint, it can send data in a very reasonable distance to a server, up to the cloud, in a very, very durable, very sustainable type of way for collection of data and analysis. We're now seeing the emergence of application-based sensors, where sensors are being created for specific markets and specific product categories, whether it's automotive, HVAC, and other types of industrial products, certainly showing up in all kinds of interesting consumer applications as well. And the other thing that has been brought up is these sensors increasingly are utilizing very low levels of power, because in many cases they may not have a constant electric current running to them. So battery power and the ability to use power in a very efficient manner becomes very, very important. So these kind of devices are showing up all over the place, whether it's in temperature-based devices, whether it's devices that are in the medical community, for example, other industrial capabilities. And by the way, these sensors have incredibly tremendous levels of precision. They're just not binary anymore in terms of yes or no to a particular type of activity that's going on. They're providing data in highly sensitive, highly precise type of ways. And the thing I have to bring up here, because where I really think the sensor category is going, is that the technology only gets accentuated when an AI layer is placed on these products that allow the sensor to act in a very intelligent, proactive, that anticipates behavior, not just simply reacts to it. So to me, and there's a whole variety of different products that kind of fit into that category, but to me, that's where the real potential and promise of these modern day sensors are going. A couple of really good examples of companies that are playing in that space right now. There's lots and lots of those examples, but there's a company out in Los Gatos, California called Superior Sensor Technology that has really an interesting approach to sensors with an SoC kind of approach that creates subsystems. They have a unique architecture that can optimize the sensors for specific customer end applications, which drives better performance. They even have the capability of replacing up to 8 competing sensors in a product, and they play very well in the medical HVAC area. There's even a company out there called Open Sensors, which makes a very interesting set of inexpensive battery-operated sensors to monitor foot traffic in buildings for occupancy levels and can monitor air quality. So that's a really interesting example of a technology of a product that are really changing kind of the landscape. And it's particularly interesting because we're now coming back out of the pandemic. So that's my insight on some of the usage models that are starting to appear. And let me turn the presentation over to Sheng.
Hello, everybody. Can you see me and hear me well? As Roger mentioned, I'm currently a faculty here at UC San Diego. I'm part of the center called the Center for Wearable Sensors, and it's an agile research center. What does agile mean? It basically means our center responds to those industrial needs quickly, and we make a fast prototype that is, customized for addressing any industrial needs. And our overarching goal is to develop those next generation sensors and systems for tackling those big questions and grand challenges that are facing this wearable sensor community, especially defined by the needs of these industrial partners. And our sensor is very interdisciplinary. Our leadership is Joe Wang, who is a renowned electrochemist, and Patrick is a circuit expert. So I'm more focusing on those flexible printed electronic materials, as Roger was mentioning. And in our center, we also work closely with clinicians and also design institute faculties to make those sensors like more acceptable by those end users. So in our center, we have a wide range of expertise, from chemical, sensing, physical sensing, printed, advanced, flexible, stretchable materials, electronic interfaces, communications, wireless, energy harvesting, data science, and also, clinical trials, so on and so forth. So particularly for myself, I'm working on those wearable ultrasound technologies that can sense those signals underneath the skin. I'm sure the audience will know that wearable sensors can sense many things, but they are limited to the skin surface. Ultrasound can extend the sensing dimension to below the skin and capture those deep tissues and vital signs from the central organs non-invasively and continuously, and that opened up a new sensing dimension for the community. Right now, our center has about 10 industrial members. Actually, at any given time, they are around 10 industrial members from all over the world. So the benefits of being a partner, sitting on the board of our center include defining the research topic and the portfolio of each individual faculties. We have internal call for proposals, and those topics are typically suggested by those industrial members. And also, those industrial members have direct access to some of our unpublished and preliminary patent disclosures before they are published. And also, most importantly, the center is also a training ground for those students and postdocs, and they work on those projects that are directly of interest to our industrial members. And when they are ready to go on the market, then they are very ready to work on those projects of interest to those industrial members. So with that, I will turn on to the next speaker. Thank you.
Thank you so much. I'm Michelle Farrington. I'm the Chief Technology Officer at AFOA, the Advanced Functional Fabrics of America. We're a national manufacturing institute, one of 16 national manufacturing institutes here in the U.S., set up to help to commercialize new technologies within the manufacturing realm and reinvigorate our manufacturing base here in the United States. I am part of, as I mentioned, AFOA, which is focused on the textile industry and bringing new technologies to the textile industry. What I'm going to talk to you about today is one of the technology areas that we focus on. So while we focus on advanced functional fibers from passive to active solutions, everything from drug delivery to new materials for conduction and for sensing and electrodes within the textile world, we very much focus on delivering integrated circuits and advanced packaging for integrated circuits for a textile format as well. And that's some of the technology that we have been commercializing and working on at AFOA headquarters in particular. So just talk to you a little bit about this. The fiber formation process for these advanced functional fibers is very similar to the fiber formation process that you'd see for fiber optic cables, where we utilize a thermally drawn process and we have polymetric preforms that we can either load with functional materials such as conducting polymers, or we can load with wires during the draw process and incorporate integrated circuits. And I think that it's important for this audience to really understand that this is open for many, many types of integrated circuits. We can run up to 6 wires in these buses, perhaps even more in the future, with a pitch of around 80 microns, and that gives you the opportunity to run integrated circuits through very large area capabilities. As everyone knows, textiles are everywhere, from not just on the clothes we wear, but also in home textiles, such as in drapes and on upholstery, as in automotive upholstery, as well as applications in composites and other industrial monitoring applications. And so we use these we basically use this fiber format, and we draw these long fibers with conductors in them, and then we through some selective material etching, we effectively create channels for integrated circuits and place the integrated circuits and recoat the polymetric portion of the fiber. And then we can spool those into large capable fibers that then can be woven, or in some cases of some new polymetric cladding, actually even knit on a knitting machine. That's a very tough order, as any of you who have participated in developing functional fibers might know, and others, there's a tight bend radius and many different mechanical constraints. But we have been able to do knitting, weaving, embroidery of these fabrics, as well as put them into applications as broad ranging as putting them into ropes for things like environmental sensing. So we can do temperature, salinity, and pressure in 100-meter long or even longer ropes for environmental monitoring. So that gives you a breadth of what we do. And I'm happy to talk about this further and talk about how integrated circuit sensors might be placed into these types of large area packaging solutions. At that, I'll hand this back over to Roger for the Q&A portion.
Thank you, lady and gentlemen. So at this point, a couple points I wanted to make. You can see the bios. I didn't want to spend a lot of time on bios, because if we talk about Dr. Zhu's bios, we'd have to break for lunch and I'd only be halfway through them, because he's such an extraordinarily brilliant guy. But the bios are located up in the upper left-hand corner. So the other thing I wanted to do is encourage everybody. We put this together such that everybody had an opportunity to talk about what they're doing, but we really wanted to make this a forum for people to be able to talk to the experts. And at this point in the program, we have arrived at that point. So please send in your questions, if you would. And And I have a question right now, and I would like to go around and get everybody's opinion on this question because, again, I'm a commercialization guy. So, Michelle, I've been back to my hometown and to visit you recently, um, and saw your wonderful lab. Can you share with us what you see on the horizon as early products that are using the technology that your members, primarily your members, that you are quite knowledgeable about what your members are doing, and certainly have helped me fill up my senses, converge with some of your members. What are some of the things that they're planning on bringing to market without stepping over confidentiality? Can you share that with us?
Absolutely. So there's some really exciting beachhead markets out there. I'll talk a little bit about a couple things that have been recently entered the market that I think are really exciting. One is a company called Nanoware. Nanoware has one of the first FDA approved medical sensing devices that is an e-textile, and so they're able. This is a device to monitor the symptoms of chronic heart failure, many other types of biomarkers that they're able to monitor over the course of any given day. And I really do feel that healthcare is a key beachhead market for e-textiles and for these types of wearables. And then another Gore has recently brought to market a worker safety product. And so they have brought together, they have joined with this company called Life Booster to develop an ergonomic monitoring product that uses distributed sensing throughout garments for workers to look at ergonomic risk. And so I think that that's another area that's quite exciting. We have a company called Hexoskin that has developed more of a fitness monitoring and health monitoring device that they have recently improved and have been sending that up to space with some of the astronauts as well as making that available to the average consumer. So those are a couple of key areas that I could highlight.
Oh, hey, Dr. Zhu, are you there?
Yes, I'm here. Yeah.
Very pretty little girl there.
Yes, that's actually my new friend. It's my friend's daughter. Yeah, everybody thought it was my daughter. No, actually, yeah,
I
it's my
see.
new
I see.
friend, Amy.
Well, good, good,
She's
good.
gone now.
So,
Yeah.
so Dr. Zhu, along the lines of what Michelle did so well, I know, because I've been to your lab, as you know, many, many times. I like to come to UC San Diego. It's just such a great place to go to, right? And
Yeah, especially during the winter time. Yeah.
especially during the wintertime, right? So, can you tell us what you and Joe Wang and all of your colleagues? First of all, how many people does Joe have in that wearables group? How many people are in the
Well,
wearables group?
well, that's a good question. He actually has two hats. Obviously, he's a PI of his lab, and that has around 40 people of postdocs and graduate students. And he's also the center director for these wearable sensors, right? I was just introducing. And in that center, there are around like 25, faculties, ranging from all departments in the entire university.
Yeah. That's a lot. That's a lot of very smart people working on projects. So, is there anything that you can share with us about some of the work that's been done by you and Joe and your colleagues that might be coming to your local Costco?
Yeah,
Tell us
that's a
about
good point. Yeah.
wearables that are approaching or have entered the market that are using the technologies that are being developed in your laboratory.
Well, that's a very good point. Actually, we are collaborating with Joe on this combined glucose sensor and blood pressure sensor together. And I'm sure those two are vital signs that affecting millions of people, right? And one unique approach of like our blood pressure sensor is that this is non-invasive and continuous. It can be measuring those blood pressure at anywhere from the body. People mostly use this so-called cuff. I'm sure you are very familiar with this, but a cuff has two major limitations. Cuff can only give you two values, systolic and diastolic blood pressure, but your blood pressure is actually very dynamic. It's changing every minute, if it's not every second. So then the cuff really gives you two snapshots of what's really going on in this entire movie, right? So our device can give you like a very high temporal resolution. We can measure 5,000 times of blood pressure every second. So you can imagine how frequent that is. Maybe it's more than enough, but we offer this capability out there. And this wearable patch is like a sticker. It's like a tattoo that it can be put on the human body for continuous monitoring at anywhere. Right. So this is one thing. Another major limitation with the cuff is it's only measuring the blood pressure in your finger or in your arm or in the wrist. Probably you have heard this, blood pressure product called the Omron. Is a wrist watch, and it's actually a miniaturized cuff on the wrist. So it has this, air, inflation, deflation. It's kind of disturbing, during night use. So all of that is silent. It does not have those, air, inflation, deflation. So it's not disturbing your daily activities. It's not interrupting your sleep. So those are the two major benefits we can offer to the community. And actually, I'm now starting a company to commercialize this technology, and we are now in the round of pre-seed fundraising. And we got some NIH, funding, non-diluting, and we are trying to do some clinical validation right now to get more data, show the accuracy of our device, and then use that to apply for FDA clearance. And I'm sure Joe is doing a lot of amazing work on those glucose sensing, and he has already spin off quite a few startup companies trying to commercialize these speakers for monitor glucose level. Yeah, so that's two major things that I want to highlight from our center.
Great. Well, good luck with your new business. I'm sure that we'll be seeing you on TV in the next year or so as the head of a new company that's just gotten round, say, of $500 million or something like that. Hey,
Thank
so
you.
Mark,
Yeah, I'm
so
sure.
Mark,
Yeah.
wanted to talk to you. You had a very fascinating presentation, and thank you for that. Can you talk a little bit about how you talked a little bit about AI was adding value. AI was adding value, and I think the real question here for we, I think was I'm speaking. I may be speaking for everybody. Uh, we censor people. I'm a hardware guy. I was a designer many years ago. I love hardware. I'm not much of a software guy, but talking to our dear friend Janusz Brzyk, and God rest his soul, because he just passed last week. If you folks don't know that, um, Janusz told me in one of our many dinners that going and trying to make money, and he started 11 or 12 sensor companies. Making money with a sensor was a fool's errand. He didn't use those words, but it's a fool's errand. And what he's done in Echo, which just got $220 million round C for their portable PMUT ultrasonic uh, sensing solution, ultrasound imaging, was what I think you're talking about, and that is adding software, adding this, adding that. Can you tell us a little bit more about what you're seeing with your clients and otherwise as to some of the functionalities that they're adding to the basic sensor to make those sensors have a higher value for the marketplace?
Yeah, it's a real good question. I mean, what I meant by the AI comment was that I just think that the AI layer adds a lot more value in terms of what the basic sensor provides in terms of capability. I mean, a very basic example might be a Nest thermostat. a Nest thermostat's interesting that I can, remotely turn off my air conditioning or turn on my air conditioning. It gets really interesting when you add that intelligence level that knows that I'm outside the house. I forgot that I turned off the air conditioning, and the sensors are aware that it should shut down the air conditioning because I'm not home, whether it's via geofencing or in the case of Nest, it uses your mobile phone as, hey, I'm not home, so it turns that off. But I do think that the AI component is extremely critical because it just adds an exponential amount of value in terms of anticipating behavior, whether it's in an industrial application, whether it's in a medical application. One of the companies I mentioned before that's doing some really interesting work in that area in terms of not just providing the sensor functionality, but actually taking much more of a traditional system on chip SoC type of approach is Superior Sensors, which is out of Los Gatos, California. They're doing some really interesting things where the actual capability is replacing what multiple sensors would have to provide from a capability standpoint. So it's actually almost kind of like a subsystem type of approach. So that's it's almost becoming, and I hate to use this example, but it's almost like the Swiss Army knife of sensors in the category that it plays in. But I think that long term, a lot of the devices and usage models and capabilities we've been talking about, I think will increasingly taking on that approach, because not only can it take advantage of smaller sizes, which are going into devices that could never have comprehended sensors before. I think that's a big deal. But it utilizes low levels of power, which is critical, and these capabilities. And at the end of the day, it's technology that's very durable. A lot of the things that we've been talking about, when they show up in industrial applications, you have to be able to depend on them 24/7. They can't work in a very sub-optimized life cycle type of way. They really have to perform in sometimes very stressful environments. So hopefully that gives you some insight to the question you asked me, Roger.
Yeah, well, thank you. Next question, Michelle. Based on some of the things that you and I saw when we were at the WEAR conference in June, down in Phoenix area. It was fascinating to me to see a lot of the technology that's out there that's wearable and also functional fabric-y, if I can use that word. And do you like the word smart textiles, functional? What's your favorite to describe all this stuff?
Oh,
so
boy.
I don't insult you.
It's not insulting at all. Actually, there's a big, debate within the community. What is a smart textile versus what is an e-textile versus what is an advanced functional fabric? So don't feel that you're alone here.
I want to make sure that I'm talking the talk here. I want to talk. I want to talk the talk.
In the case where we're talking about electronics in the textile itself, that's e-textiles. We can at least leave it at that, and then
we got to get the lexicon right. But the question is, and I'm going to talk to Dr. Zhu as well. If you're looking at a solution and not a sensor, and we know the sensor is an enabling element of a solution, and without the sensor, there's no solution.
Yeah.
What are the challenges that Dr. Zhu and you and Mark, you're certainly welcome, even though you're a Boston College guy, not a Northeastern guy, to join in here. You know that Mark went to Boston College?
I didn't know that.
Yeah.
Don't hold that against me, Roger. I asked you before the call not to hold that against me.
But here's a challenge.
I mean,
how do you interface these sensor modalities, technologies, whatever you want to call that sensor element, to all the other functionalities that need to be a part of the system from a connectivity point of view? My concern is you got all these technologies, but if you throw them in your Maytag clothes washer, you find it in the lint filter. What are the challenges here of making a sensor and integrating it into a product? So Michelle, ladies first.
Huh? Really amazing question. So in the case of e-textiles, where you use an integrated circuit as a sensor, which we also have textile-based sensors. So I'll leave that for a different day. But when you're talking about an integrated circuit into the sensor, or you're talking connectivity, so you may be talking about the radio, Bluetooth radio, and the microcontroller and other things. Currently, state of the art for products out there today is that the sensors can be distributed and typically put on little satellite flexible boards attached via conductive yarns, and they're encapsulated. But the sensor hub that includes a battery is often detached for washing and charging. We are working on ways to get to washable sensor hubs, because that's really where people need to be in terms of reducing the user barriers and user adoption barriers, is to not have to worry about your clothes as a gadget. Have to worry about nothing other than wearing them, which means you have to
Yeah.
charge them in a wireless charging drawer or a smart closet in the future, and you need to be able to wash the electronics. So we're at the point where we can be washing the sensors, largely because you can make them really tiny and you can do a good job of encapsulation. But in the case of the large sensor hubs with the batteries, it's more difficult, and we are continuing to work on that.
Yeah, thank you. And another part of that question before we go to Dr. Zhu is the following. Are you looking at what I call like pseudo monolithic integration, where these functionalities that you talked about are realized in yarn, in fabric, so you have a monolithic solution that doesn't really have, like an integrated integrated circuit, where there is no challenges because everything is all together and it's encapsulated, perhaps, but it's its own system.
Yes, that's that functional fiber. And you can think of it as distributed monolithic solutions. So you would have distributed sensing through, and potentially eventually, if you use an interposer board, you can talk about even adding in your memory and adding in your signal processing and adding in other things. But you really want this to be a tiny fiber in order for it to be effective as a yarn. And so what you do is you distribute the ICs along the length of the fiber. So you have to think of it more as a long, super long bus, wired bus in this case, with the distributed chips along the length. So you have this really extremely long length that you can be playing with, and so that's how you need to incorporate these distributed units.
Thank you. So Sheng, back to you. How are you and your colleagues at the lab addressing this concept of integration? So once you put the tattoo down, and the tattoo is making all these measurements on, hydration levels, or perspiration, biomarkers, how are you getting that basic low level electrochemical signal to something that can be used by the wearer?
That's certainly a grand challenge, Roger. And I'm very aware of the approach Michelle was mentioning, distributed sensing and computing along the fiber. I think it's a very promising and a very exciting new direction for the future. So for me, for our group, we are trying to integrate those integrated circuits, low power electronics, together on the same platform with the sensors, and they all integrate together. So there are two challenges, for this integration. One challenge is obviously data transmission rate, and for the particular case of ultrasound, the data rate, generation rate, is much larger than the traditional, you mentioned, the bioimpedance, those hydration, or skin temperature, those type of things. Because ultrasound is an imaging system, it's an image rather than those data points. So there's lots of data generated every second, megabyte. So to satisfy the need for such a large data bandwidth, we'll have to use those Wi-Fi rather than those Bluetooth, and the Wi-Fi right? And that brings to another challenge, which is the power consumption. So then we do not want to integrate a very very large bulk size of battery together with the patch, right? That loses the whole point. So we will have to use some smart strategies to lower down the power consumption, and I think that can be achieved in two ways. One is to lower down the power consumption of the sensor itself, say by duty cycle everything. Within 1 second, we only turn on a few like a millisecond, and that means during the rest of this 990 millisecond something, the sensor are just idle. Then it's still considered as a continuous because we are sampling only a few milliseconds every second, right? So it's still continuous basis. And the second approach is to enhance the power density of those energy storage devices. And there's also like a research direction in Joe's group and a little bit in myself group as well, is to integrate those energy harvest devices so that we can gradually charge those batteries so that we can extend the lifetime of those batteries. And those energy harvesting modalities can be either from mechanical, like using those piezoelectrics or triboelectrics, or even chemicals, right, from your sweat, from glucose, those biofuel cell, or even those like those solar, right, sunlight, using those wearable solar cells based on perovskites, so on and so forth. I think the field is very exciting, and there are certainly a lot of challenges, but we are making slow progress. We are making slowly but surely progress towards our goal. Yeah.
Great. Well, thank you. Mark?
Mark, you are muted.
Yes. Can you hear
Hey,
me?
so Mark, I have a question. Were you going to ask me a
Oh,
question?
go ahead. Yeah, well,
I
I was just going to add a couple of comments here. Is that just to take this out of the material sciences realm for a second? I think the discussion and that could be a potential headwind to a lot of this wonderful technology that's coming to market. I am convinced that a lot of the problems we've been talking about will be solved over the coming quarters and coming years. But to talk a little bit about security and privacy, because as this technology becomes more compelling, more effortless, that, hey, I'm wearing a wearable piece of clothing that I don't even realize that I'm wearing something like that.
You
We have
read
to be
my
cognizant
mind. I
that-
was going to ask you that question.
Yeah. See,
Go ahead.
look how we think alike.
Go
We
ahead.
think alike, Roger.
Please finish.
And I just think that that's a discussion that the market and the industry need to have, because I'm not sure a lot of people will be crazy if there's a popular line of sneakers out there or clothing or whatever that has some type of wonderful sensor that provides some great data from a health and medical management standpoint, and that data somehow gets compromised. That those risks even operate, as you know, in the business environment as well. If I have a piece of sensor technology in a CPAP device, I'm not sure I want that technology at risk that could be exploited by bad actors. So again, I don't think it's a huge problem, because a lot of the technologies we're talking about, especially at the integration level, are comprehending security in mind. So that's extremely helpful. But at the end of the day, I think it's something we need to be cognizant of.
Totally agree. The other thing I wanted to, I think we are probably reaching the end of our period. Is that right, Lucia? We have a couple minutes to go. Are you there? I presume we do. But
Yeah, I think we should turn this on.
the question that I wanted to just, I feel like Judy Woodruff on a news hour. You got 25 milliseconds. Give me an answer to this question? But no, I'm gonna give it 30 seconds. What do you see, if anything, as the effect of COVID? We haven't talked about COVID. Let's get out of talking about sensors. Let's talk about kind of socio cultural things going on. What do you see, starting with Michelle, the effect of COVID on the progress of bringing the technology that you and your AFOA colleagues are developing to the marketplace? What impact do you see, and what impact do you foresee with COVID?
So I'd say, first of all, with respect to the impact on the work, there's not been a big impact on the sort of research and early technology introduction side of things. But in terms of product development, there were many companies who, of course, had to switch their production to put PPE, for example. Many textile companies decided to invest in other areas, and so we're now just seeing a resurgence in investment and interest in bringing new technologies to market in that space.
Yeah. Now, Dr. Zhu, I just did my big annual report card program and asked people what they saw going on in R&D and COVID. And one of the points that came out, I want to find out from you, how affected was your team from COVID and the inability to travel from places like China or India or Munich, Germany? Did that have a significant effect on your person power at UC San Diego to develop your programs?
Well, I think the impact is threefold. The first thing is during COVID, the campus locked down, right? That's a direct major impact to the research of in my group. Then we have to operate on a reduced, human and only like 2 or 3 people allowed in the lab. Everything slowed down. The second thing is COVID significantly reduced the amount of students we can recruit from overseas, and our projects get kicked off, and we cannot hire people. Then we cannot deliver those things, right? Then the program officers give us a hard time, a lot of pressure on this regard. The third thing is, we cannot travel, as much, to communicate, find out collaborators. But fortunately, everything, has already started open up. And right now, I'm attending the MIS in Boston, and I just see a lot of old faces, and it's so exciting to see everybody in 3D again. With that being said, I would say COVID still has left us a positive impact, which is, everybody now gets used to the Zoom, which is this online experience, for everybody, right? So that is more efficient, and we can, have those frequent and, direct discussions, rather than, fly over to a new place. So I think, there are pros and cons.
So another impact issue regarding COVID, and I'm going to ask Mark to swing at this one, is supply chain. From working with the clients that you have, Mark, has supply chain issues had an adverse effect in the way they were able to bring their products to the marketplace?
The answer is an emphatic yes. I mean, there's several clients that I have that has absolutely been impacted by supply chain issues. I mean, you're seeing is happening right now with Apple. They're having problems supplying some of their iPhone 14s, which is their most popular line of phones. So it's not going to be a happy holiday for many people later this year. But in general, I think that what's happened in the sensor space is being shared across the electronic space in general. I mean, it's just putting tremendous burdens. And a lot of these large companies and small companies, by the way, because a lot of the companies we've been talking about are relatively small. They're not at the mammoth size of Apple, but they don't have the supply chain resources that an Apple has. So in many cases, they're looking to diversify their supply chain, not be as reliant on China, moving their supply chain capability as much as they can to areas outside of China, to Mexico and to Vietnam and other places like that. But that takes time. It's not something that you can flip a switch and make happen right away. So there's certainly been an impact that presumably we'll get out of shortly. But there are still some long-term strategies that have to be implemented, because there is concern that if a pandemic happened once again, obviously the dependence on China is an ongoing big deal across the technology space. But there's no question there has been an impact.
Let me ask you this: Have your clients, or through your observations, seen strategies that can be adopted to mitigate this supply chain impact? What
Well, yeah,
what are some of the strategies that people are adopting to say, well, yeah, and we got a solution to that. We're not going to step on the landmine. We're going to walk around it. Can you share some mitigating strategies that might be in place right now?
Well, in many cases, they're implementing strategies that they would rather not like to implement. For example, build ahead, where they're building more, trying to build more production, more inventory than they normally would in the attempt to anticipate supply chain gaps. Kind of a just-in-time type of approach has always really been the model that a lot of technology companies like to pursue because it keeps the cost of their inventory as low as possible. Now, in product areas where the technology is not as changing as quickly, like in Intel, for example, where they rev new processor all the time, it's very difficult for them to pursue that because you don't want to be caught with, old inventory. But in many cases, they're employing tactics that they would rather not like to because there's risk associated with that, and you have to have very good forecasting activity. Now, in some of these more discrete industrial markets, it's a little bit easier to forecast because the numbers are not huge, but a lot of them are planning, frankly, to offshore more of their production outside. They're pursuing strategies where they're building levels of inventory, especially if they have a subsystem type of capability, where they can try to kind of de-risk a lot of the delivery to their customers.
Yeah, and I'm going to kind of chime in on that based on the market study on my report card and a couple of studies that I've done and published in uh, Fierce Electronics and Nasdaq Briefs. Some of the people are saying attempt to do higher levels of vertical integration in house to be less dependent on outside vendors. In other words, that's easy to say, but building internal infrastructure takes a lot of time, a lot of money. So, that's kind of my concluding remark. So, it's time to wrap up. How about some concluding comments, starting with Dr. Zhu? 30 seconds, Dr. Zhu. What do you have to tell us in 30 seconds?
Well, great. I think this is a wonderful platform to bring everybody together to share ideas and perspectives and talk about the challenges in the field. I think sensors still has a lot of room to go to exert the impact on people's life. And welcome to join this field. And I'm happy to talk with anybody after that. By the way, Joe just said convey his best regards to you, Roger.
Oh, and mine,
Joe
mine back to him, and also my buddy Al Pisano, everybody's boss down there. Say hello to Al for
Okay,
me.
sounds good.
So,
Okay,
Michelle,
we'll do. We'll do.
thank you. Michelle, 30 seconds from you.
Yes, in conclusion, we love to collaborate with those who are bringing sensors to market and looking to um, bring sensors to a completely new channel, a channel that has not been exploited. We're very happy to work together with IC manufacturers and others to collaborate and hopefully utilize this large area sensing platform.
Great. And Mark, you will be the man with the last word here.
Well, and thank you, Roger, for permitting me to be on the panel, despite the fact that I went to Boston College. I guess the concluding comment I would just make is that this is going to be, I think we've just seen a modest taste of what's capable and the potential of sensors. Again, when you add that AI level that I talked about before, with some of the material sciences things that are happening in this space, we're going to see these kind of capabilities show up in products that just a couple of years ago, we would have said that would be virtually impossible to do. So this is an exciting area. Keep an eye in this space because it's going to keep changing. And I think these technologies do have the capability of changing people's lives in a very profound way. And it's exciting to be part of that.
Well, thank you all for being so kind and participate in this panel. And thank you all for those who have watched us. And I would presume that my QuestTech colleagues will make all of these presentations in slides. I know they asked if they could have the slides, and I gave them my agreement. And if anybody wants to talk to any of us, everybody, nobody said no. I guess I'm just assuming everybody said yes. It's okay for people to email you on the emails that I put up at the first slide. Is that acceptable then?
Sure.
Everybody's
Thank you,
on.
Roger.
Everyone's on. Well, thank you all, and I'll give it back to Lucia and the QuestTech team, and thanks for your attention.
Thank you all for a great session. That wraps up the first session for today. On behalf of Fierce Electronics, I would like to thank all of our speakers, as well as our sponsors, Rohde & Schwartz and Microchip.